Hello guys, and welcome to Help Grow Academy. In today's class, we're going to be treating algebraic fractions. We'll know the meaning of algebraic fractions. We'll talk about the types of algebraic fractions. We'll also talk about basic rules in solving algebraic equations, and we'll talk about the basic operations with algebraic fractions. The first we have here says, what are algebraic fractions? Algebraic fraction simply refers to a fraction in which the numerator or the denominator has an algebraic expression. That is, an expression involving variables like x, y, a, b, and so on. So any equation you come across that has this variable in form of a fraction is called an algebraic fraction. We have examples of algebraic fractions. We have x over 2x plus 1. This is an example of an algebraic fraction. X here is the numerator and 2x plus 1 here is the denominator. We also have another example here. We have 3a plus b all over 2a minus 1. This is another example of an algebraic fraction here, where 3a plus b is the numerator having a variable and 2a minus 1 is the denominator having a variable. The variable here is a and b, while here the variable is what? X for the denominator and the numerator. We have the basic rules for solving algebraic fractions. The first one, known as the difference of two squares, where we have x squared minus y squared. These are two different squares. You have the first square and the second square. Now, the difference of two squares, you have x minus y into x plus y. If you expand this stuff, you have this. Let's check if it's correct. Here you have, this multiplies this, you have x squared. This multiplies the second term, you have plus xy. Minus y will multiply the first term, which is plus x. You're going to have minus xy, and minus y will multiply plus y to give us what? Minus y squared. Now this would cancel this. We're left with what? X squared minus y squared. Therefore, when you have an algebraic expression in this format, what you need to do is to express it like this. You pick them, separate them, and then one of them should have a positive sign while the other should have a negative sign. That is what you get when you have difference of two squares. The second one, which is x plus y squared. X plus y. Yes, this talks about the perfect squares. Here you have x plus y all raised to power 2. Now this is the same thing as x plus y multiplying itself twice. You have x plus y into x plus y. When x multiplies x, you have x squared. When x multiplies the other term, you have what? Plus xy. When y multiplies the first term, which is x, y times x will give us plus xy, and y times y will give us plus y squared. Now this is the same thing as x squared. You have xy plus xy. When you add them together, you have 2xy plus y squared. So when you have a perfect square, all you need to do is to split them into two different brackets, just as we have here, and it's going to give us this. So this expression is the same as this. This particular rule or this basic rule is called the perfect squares. Perfect squares. The third one here says x over minus y is equal to minus x over y. What this particular rule is talking about is that the negative sign does not only affect the denominator here, it affects both the numerator and the denominator. The same thing is applied here. In this fourth rule, the negative sign does not affect only the numerator here, it affects both the numerator and the denominator. So minus x all over y is the same thing as minus x over y. The fifth one says x over y is equal to m over y. When you have an expression like this and you see an equality sign, all you need to do is to pick the denominator, they cancel out, and then you're left with what? M is equal to y. X is equal to m. When you have an expression like this and the denominator are the same, equating each other, all you need to do is to cancel them out, which gives us x is equal to m. The sixth one here says x squared minus 5x plus 6. This is a quadratic equation. A quadratic equation is an equation in which the highest power of the unknown is 2. If you have a quadratic equation like this, what should come to your mind is to factorize it. When it comes to factorization, you find two numbers that when you add them together gives you the middle term, and when you multiply them it gives you the constant, which is c. So for the sixth rule, we have x squared minus 5x plus 6. This will give us, when you're asked to factorize something like this, like I said, you find two numbers that when you add them together gives you minus 5, and when you multiply them it's going to give you the constant, which is plus 6. So let's try minus 2 and minus 3. Two numbers that when you add them together gives us minus 5, and when you multiply them gives us 6. So if you have minus 2 plus minus 3, minus 2 plus minus 3 will give us what? Minus 5. So the first condition is satisfied, which is this. Let's check if it's going to satisfy the second condition, whereby we will multiply them together. It's going to give us 6. We have minus 2 times minus 3. Minus times minus gives us what? Plus. 2 times 3 will give us what? 6. This other one also satisfies the second condition. Therefore, the two numbers that when you multiply them together gives us the constant, and when we add them together gives us the middle term here. It's minus 2 and minus 3. We have the two terms minus 2 and minus 3. Now we write this equation in this format: x squared minus, instead of writing this stuff, we replace it with these two values. Instead of writing the middle number, we replace it with these two values, which is minus 2 and minus 3. Now say minus 2, we attach x to it, which is minus 2x. The next value we have is minus 3x. Then we'll bring this down, plus 6. Don't forget, this value replaces the middle value here, the middle number, which is 5x. At this point, we can factorize. This is equal to 0. At this point, we can factorize. There's something common here. Here we have x. X squared divided by x, you have x minus 2x divided by x, you have 2 minus something is common here. If you factorize this, you have 3. 3x divided by 3, you have x plus 6 divided by 3, you have, sorry, this is minus 6 divided by 3, you have 2. This is equal to 0. Now, if you check here, you have the same thing in this bracket and you have this in the same bracket. Don't forget, this is not plus. If you put plus here, you won't get the correct answer. Let's assume you put a positive sign here. Plus minus 3 times x will give us minus 3x. Minus times plus will give us what? Minus 3 times 2 gives us 6, which is not the same thing as this expression here. So the correct thing you're meant to put here is what? A negative sign. When minus times minus, when minus multiplies minus, you have plus, which is the same thing as this. So we are correct. Now, if you observe, these two brackets will have the same value. So we pick one, which is x minus 2. The second term, this one's outside the brackets, we pick them. We have x minus 3 equal to 0. A quadratic equation of this format, when you're asked to factorize it, this is what you get as your final answer. So, we are done with this. Let's move on to basic operations with algebraic fractions. Basic operations with algebraic fractions. For basic operations with algebraic fractions, the first we have here says simplifying. Now, when we have a question like this, look at this example, x squared minus 9 divided by x squared minus x minus 6. What you need to do here, when you're given a question like this and they say you should simplify, what you need to do is you factor both the numerator and the denominator. Then you cancel out their common factors. This, when looking at this question, you know that this is a difference of 2 squares. Same thing as this. Because this is the same thing as x squared minus 3 squared all over x squared minus x minus 6. Now, this particular one, the numerator is now looking like this. When you're given a question like this, you remember that this is a difference of 2 squares. You have x squared and you have 3 squared, 2 different squares. So what you do, you have x minus 3 into x plus 3. This is for the numerator. Now for the denominator, this is a quadratic equation. Let's factorize it. Like I said, you find two numbers that when you add them together, gives us this, and when you multiply them, it gives us this. So let's try two numbers that when you add them together, it's going to give us 1. And when you multiply them, it's going to give us this. So let's try minus 3 plus and plus 2. Let's check if this satisfies the condition. We have minus 3 times plus 2. This will give us minus 6. And we have minus 3 plus minus 2. This will give us what? Minus 1. Therefore, it satisfies the condition we stated earlier. We know that when we factorize this, we're going to have minus 3 and minus 2. Now we have here to be what? Minus 3. We have x minus 3 and what? X plus. This is x plus 2. Now if you observe, there's something common here. This will cancel this. We're left with what? X plus 3 divided by x plus 2. This is our final answer. This is the lowest term. You cannot simplify this question further. This is where we stop. Here says, the second one says addition and subtraction of algebraic fraction. When you have something like this, what you need to do is, you have 1 over x plus 2 over x plus 1. The first step, you have to find the LCM of these two fractions. The LCM of x and x plus 1 is x into x plus 1. This is the LCM. Now what you do is, you say this divided by this, you're left with what? X plus 1. X plus 1 times 1 will give us x plus 1. You enclose it in a bracket, plus this divided by this denominator here is going to give us what? X. By that I mean divided by x plus 1. This cancel this, they go out, you're left with x. X times 2 will give you 2x. Now when you add this together, you're going to have 2x plus x plus 1, all divided by x into x plus 1. There's something common here, right? Yet this will take away this. You are left with 2 plus x plus 1 all into x plus 1. So this is our final answer. For multiplication now, when you have an expression like this, x over x plus 1 times x plus 3 over x, what you need to do is you multiply the two numerators and multiply the two denominators. By that we mean this is the same thing as x into x plus 3 divided by, this is x times x plus 1 will give us x into x plus 1. There's something common here, right? Yet x is common, so x will cancel x. This will give us what? X plus 3 over x plus 1. X plus 1. So this is our final answer. The next we have here is the fourth basic operation known as division. Division of algebraic fraction. For division of algebraic fractions, what you have to do is you take the inverse of the second term and multiply it. The inverse, I mean the reciprocal of this second term, then you multiply it. When you take the reciprocal, this denominator here comes up and the numerator goes down. The sign changes from division to multiplication. We have a squared minus 1 over a plus 1 times, this one comes up, you have a plus 1 over a minus 1. This is the same thing as a squared minus 1 into a plus 1 divided by what? A plus 1 into what? A minus 1. Now there's something common here. This will cancel this. You're left with a squared minus 1 all over what? A minus 1. Now this is our final answer. So when you have an algebraic fraction of this form involving division, this is what you need to do. Take the inverse of the second term, the sign changes from division to multiplication, then you simplify. Question 1 says, simplify x squared minus 4 divided by x squared minus x minus 6. For the numerator, we have x squared minus 4. This is the same thing as x squared minus 2 squared. Don't forget, from difference of 2 squared, we say this is equal to x minus 2 into x plus 2. For this second term now, we have x squared minus x minus 6. This is a quadratic equation. We find two numbers that when we add them together gives us the middle term, which is minus 1, and when we multiply them it gives us the constant, which is minus 6. Now those two numbers are what? Minus 3 and what? Plus 2. When you add them it gives you minus 1, and when you multiply them it gives you minus 6. Therefore we have x minus 3 and what? X plus 2. Now we will substitute this into this equation. Instead of writing x squared minus 4 all over x squared minus x minus 6 is equal to x squared minus 4 is the same thing as this, x minus 2 into x plus 2 divided by x squared minus 6 minus x minus 6 is the same thing as this, which is x minus 3 into x plus 2. This will cancel out. Therefore, we are left with what? X minus 2 all over x minus 3. This is the final answer. Question 2 says simplify 3x divided by x squared minus 9 divided by x all over x plus 3. Now what you need to do is first you simplify this, you break this down. This is the same thing as x squared minus 9 is the same thing as x squared minus 3 squared. From difference of 2 squared, we have that this is equal to x minus 3 into x plus 3. Now we have gotten this. Let's substitute it for x squared minus 9. Let's substitute this into this equation. We have this to be 3x divided by, instead of x squared minus 9, we have x minus 3 into x plus 3. This is divided by x over x plus 3. Now we said something where we have an algebraic fraction like this dividing themselves. We take the inverse of the second term and we multiply. By that we have 3x over x minus 3 into x plus 3 multiplied by, this one becomes the numerator. Now we have x plus 3 divided by x. All we have to do here is just to multiply the two numerators together and divide it by the two denominators. We also multiply the two denominators. We have here to be 3x into x plus 3, all divided by, here we have x into x minus 3 into what? X plus 3. Is there anything common? Yes. They cancel out. We have 3x divided by x into x minus 3. This will also cancel this. We are left with what? 3 over x minus 3. It says add 2 all over x plus 3 all over x plus 1. When you have this kind of equation, the first thing I said, you take the LCM of the two of the denominators. The LCM of x and x plus 1 is what? X into x plus 1. Now I've gotten the LCM. This is the LCM of these two values. Now you say x divided by this, you have x plus 1. X plus 1 times 2, you have 2 into x plus 1. The same thing happens here. This will cancel this. You're left with what? X. X times 3, you have plus 3x. This is equal to 2 into x plus 1 plus 3x over x into x plus 1. Now you expand this bracket with these two. 2 times x, you have 2x plus 2 times 1, you have 2 plus 3x divided by x into x plus 1. When you collect like terms here, you have 2x and you have 3x. 2x plus 3x will give you what? 5x plus 2 divided by x into what? X plus 1. This is our final answer because we can't simplify any. Question 4 says simplify x squared minus 1 all over x squared plus x. Now here we have the numerator, which is x squared minus 1. This is the same thing as x squared minus 1 squared. Yet, because 1 times 1 is the same thing as 1, so this is the same thing as 1 squared. From difference of 2 squares, we have x minus 1 into x plus 1. Now we have gotten that. Let's substitute this into x squared minus 1. So instead of writing x squared minus 1 in this equation, we replace it with this. We have x squared minus 1 all over x squared plus x is equal to this for x squared minus 1. We have x minus 1 into x plus 1 all divided by, you have x squared plus x. If we factorize it, there's something common here. We have x. X is common. X squared divided by x, you have x plus x divided by x, you have 1. So this, we bring it here. X into x plus 1. Is there anything common that can cancel out? Yes. Here you have x plus 1. You have x plus 1. They cancel out. You're left with what? This value. You're left with x minus 1 divided by x.